Hi, and welcome to question 5 of the 2023 Maths Junior Cert Higher Level. And we're looking here at a 15-mark question. So it's basically around probability, and all three parts are marked together, which actually in this year's exam paper was similar to question 1. So I'll read part A. The table below shows that the outcome when the numbers A and B are multiplied together for A, B are elements of n. Now that simply means that A and B are natural numbers, which means they can only be positive whole numbers. So 1, 2, 3, whatever. 0 is no longer considered a natural number because they're often referred to as the counting numbers, and you'd only count with 1, 2, 3, whatever. So the important words there are what's the outcome gives me an indication that it's probability, okay, and the numbers A and B doesn't matter, it could be X, Y, that they're multiplied together. Okay, so two numbers multiplied together. Write odd or even. Now, an even number is a number that's evenly divisible by two. So, or simply put, if you divide by two, you'll always get another whole number. Okay. Um, Now, an odd number is not even. Is one way of putting it. That doesn't happen. So write odd or even in each box to complete each of the mathematical statements correctly. The first one is done for. So is it true, and it gives us suppose in general, A times B, which is what they stated up the top, equals C. So it gives another number. And then the first example that they've done is an even number. So let's say, for example, 2 times 4. Does that always give an even number? It does. Okay, now I just realized I'm colorblind. My ink is probably in red by default, but I can't tell. So if we keep continuing on that, like odd by odd, like let's see, what would happen if I multiply an odd number by an odd number? So I go, well, like 3, yeah, 3 by 7 is an odd number. That gives me 21. You can just tap it away in the calculator, okay? So go odd by odd always gives me, is this divisible by 2 to give a whole number? No. Okay. So odd by odd always seems to be giving me an odd answer. And I won't make a dad joke. Odd times even. What does that do? And that's where the real test will happen. So look, 2 times 3. Okay. 3 is odd. That's 6. Maybe 2 by 7. We use 7 already. That's 14. Right. They've both given even numbers. Okay, so let's try another test, different number than 2. Let's go 3 times 4, and that gives 12. So I'm always getting an even number, so I'd suggest that that's where an even would come in. Oftentimes, just tapping away in the calculator can be of great benefit. Okay, so that's the answer done in the notes. And if you want a copy of these notes, just send me an email at shanetroy@gmail.com, and I'll fire them off to you. Now, part B and C, again, these are all marked together. Okay, always worth having a look at the marking scheme. I can send them on as well, but whatever. Rory rolls a regular, unbiased, six-sided die in 3 times. Okay, so he rolls a dice 3 times. I'm going to assume it's unbiased, and so they always put that in there because dice can be tricked to make them more probable to land on a certain number. Okay, and it's quite an interesting, like whatever story. He writes down the number on each roll of the die. Okay. Part B then says complete the sample space below, showing the different possible combinations of odd and even numbers that Rory could roll. 2 possible outcomes have been filled in for you. So this is where tapping away and maybe actually having another read of the question. And I often find the times that I make mistakes, which are numerous, are because I just read the question too fast and didn't spend time focused on it. Okay, so the first sentence up here is kind of irrelevant. Okay, just stating the premise. Then so he writes down the number on each roll of the dice. So the first one there he could get an even number, an even number, an even number on the 3 times you roll the dice. He could get even, odd. Like he could get a 2 and a 2 and a 2. He could get a 2 and a 2 and a 3. Okay. Now, or he could get a 2, so that's even. and he could get a 3 and a 3, an odd and an odd. Okay. Now, could he get 333? Of course he could. Okay. Now, the order of these, in a sense, matters. So all we have to do now is fill in the remaining circumstances. Okay. So I'll start off down here. Maybe if I got now I did odd, odd, odd. What if you got an odd and then an even and then an even? Okay. Now it looks like OEE is the same as the EO, but they're in a different order. Okay. He could have got an odd first, an odd second, and then an even. Okay. He could have got an odd, then an even in the middle, and then an odd. Now here's where my stupidity and my lack of organization is going to hit me. I'm going to have to problem solve what the other one is, and my brain doesn't always do that very well. And I'm missing out on the even first, odd second, even third. So that should be it. Now, it's always worth, and this is one of these great questions that if you look at this again in 5, 10, 15 at the end of the exam, and you just redo it, you'll catch or mistakes, or we have done something the same one twice by accident. So these can be very tricky questions, so just be very careful, even though they can be simplistic for some, and totally understand that. For others, that's not quite the same way. Now, that is probability as an entire genre. So part C says each outcome in the table is equally likely. Okay, these are independent events in that scheme. Rory multiplies together the three numbers that he rolls. Find the probability that Rory will get an even number as his answer. Now, in the notes here, I've given the probability formula, which you're not actually given in the math tables, but whenever I need to remember it, I always think of the simplest circumstance I can think of in probability, which is rolling a dice. So how many things can happen in rolling a dice? Well, there's two. That's the number of possible outcomes. How many things will happen? One. So you get the 1 and 2, and that's where the 50-50 from flicking a coin comes from. So let's take a second to read it again. Rory multiplies together the three numbers that he rolls. So even, odd times even times odd, say, just as an example. Okay. Find the probability that he gets an even number as his answer. Now, I'm going to do this really directly without trying to mark too much on the paper, but you could probably write it down here in the bottom of your page. If you would multiply an even, like say, for example, 2 by 2 by 2 would give you an even answer. Damn it. Okay. I'm using a new device, an even number. Now, 2 by 2 by 3, so 2 by 2 is 4, 4 by 3 is an even number. If I go for the third one there in the first row, 2 by 3 by 3. 2 by 3 is 6. 6 by 3 is 18. That's an even answer. Now, odd by odd by odd. 3 by 3 is 9. 9 by 3 is 27. So that's an odd. Okay. Now, you see, all these other combinations would do the same thing, but you could do it. 2 by 3 is 6. 6 by 3 by 2, 6 by 2 is an even. This would give even, even, and even. Now, the number of possible things that can happen there is over 8. Okay. The number of actual evens that will happen is 7. So there's 7 in 8 chance of getting an even number and a 1 in 8 chance of getting an odd, okay, from that scenario. Now, it's not a scenario that's really used ever in any games that I know of, but who knows? One thing I did notice from the marking scheme is that if you had said 7 in 8, there was a penalty applied, or if you made the ratio 7:8, which wouldn't be less valid. Okay, so probability is always scored between 0 and 1. If you leave that as a fraction, that's cool. If you leave that as a decimal, that's cool, unless they specifically state how they want it. So that's the end of question 5. As always, if you want a copy of the notes, just send an email to shanetroy@gmail.com. Like and subscribe to get access to more playlists. See you on question 6.